Okay, now we'll start with the next chapter of derivative, which is called as rules of derivative. Chapter 3, this is rules of derivatives. It is in this chapter that you will learn most of your formulas of derivative. So in this session, what we are going to do is we are just going to write and learn the formulas down. Let's see the formulas. Derivative is written as d by dx. What we were writing as f bar of x in first principle is same as d by dx. Whether I write f bar of x or I write d by dx, they are synonymous, they are the same thing. Okay, let's move on ahead. D by dx of constant is 0. Next, d by dx of x is 1. D by dx of x square is 2x. D by dx of x cube is 3x square. D by dx of root x is 1 upon 2 root x. D by dx of 1 upon x is minus 1 upon x square. D by dx of x raised to n is nx raised to n minus 1. D by dx of a raised to x is a raised to x log a. D by dx of e raised to x is e raised to x. D by dx of log x is 1 upon x. Next, let's go ahead. D by dx of u plus minus v is du by dx plus dv by dx plus minus. Next, d by dx of uv is v derivative of u plus u derivative of v. Next, d by dx of u upon v is v derivative of u derivative of u minus u derivative of v upon v square. These were all the algebraic formulas. Now let's move on to the trigo formulas. Let's see what do the trigo formulas say. D by dx of sin x is cos x. D by dx of cos x is minus sin x. D by dx of tan x is sec square x. D by dx of cot x is minus cosec square x. D by dx of sec x is sec x tan x. D by dx of cosec x is minus cosec x cot x. Now besides these formulas, you have some other formulas, but those are inverse formulas. We will see them when we need them. At the moment, these are the only formulas that you will need. Let's see sums based on these formulas. Okay, let's see this. Before that, let's look at the formulas once again. Now, I'm going to rub these formulas. I hope by now you've written the formulas down, and we will start with the sums and see how the sums are to be done. Right? Let's start. y is equal to 1 upon x plus 2 upon x square plus 3 upon x cube plus 4 upon x raised to 4. Right? Let's see how do we do this sum, guys. Now the first thing that you have to do is write differentiate with respect to x. What do you mean by that? You multiply both the sides by d by dx. So d by dx of y is d by dx of 1 upon x plus 2 upon x square plus 3 upon x cube plus 4 upon x raised to 4. Right? So you will get dy by dx is, open the bracket. When I open the bracket, d by dx gets multiplied with every term. So you will have d by dx of 1 upon x plus d by dx of 2 upon x square plus d by dx of 3 upon x cube plus d by dx of 4 upon x raised to 4. Now d by dx of 1 upon x, I just gave you the formula, is minus 1 upon x square. Whatever is constant comes outside the derivative sign. So 2 will come out. This will become d by dx of, get x raised to 2 from denominator to numerator. When I bring it from denominator to numerator, the sign of the indice changes. So 1 upon x square becomes x raised to minus 2. Right? Same way, 3 is a constant, comes outside the derivative. This will be d x raised to minus 3. 4 is a constant, d by dx of x raised to minus 4. This is minus 1 upon x square plus 2. You will use the formula d by dx of x raised to n, which is nothing but n x raised to n minus 1. Similarly, same formula again, d by dx of x raised to n, n x raised to n minus 1, x raised to n, n x raised to n minus 1. Fine. So this is minus 1 upon x square minus 4 x raised to minus 3 can be written as, I'm converting the negative indice to positive by shifting it to the denominator. So this will become minus 4 upon x cube minus 9 upon x raised to 4 minus 16 upon x raised to 5. So that will be your answer. Let's see another sum, guys. Y is equal to 2 upon root x plus 2 upon 3x root x plus 2 upon 5x square root x. Fine. Let's see the sum. Same thing that you did in the previous sum. You will say differentiate with respect to x. That means you multiply both sides by d by dx. So d by dx of y is nothing but d by dx of 2 upon root x plus 2 upon 3x root x plus 2 upon 5x square root x. Right? Open the bracket, constants come out, d by dx root x can be written as x raised to 1 by 2. Since I am bringing it in the numerator, this will become x raised to minus 1 by 2. Similarly, 2 by 3 d by dx, 2 by 3 is a constant, so it comes outside the derivative side. X root x is nothing but x raised to 3 by 2. When I bring it in the numerator, it will become x raised to minus 3 by 2 plus 2 by 5 is a constant, d by dx x square root x is nothing but x raised to 5 by 2. When I bring it in the numerator, it will become x raised to minus 5 by 2. This is going to be 2 d by dx of x raised to n is nothing but n x raised to n minus 1 plus 2 by 3. Same formula again, d by dx of x raised to n. d by dx of x raised to n is nothing but n x raised to n minus 1. Similarly, same formula again, d by dx of x raised to n is nothing but n x raised to n minus 1. Fine, do we get this thing here? Now this is going to be 2, 2 and 2 gets cancelled, minus x minus 1 by 2 minus 1 is minus 3 by 2, 2 and 2 cancel, 3 and 3 cancel, plus into minus minus, minus 3 by 2 minus 1 is minus 5 by 2, similarly 5 and 5 cancel, 2 and 2 cancel, plus into minus minus, x raised to minus 7 by 2. Now this can be written as minus 3 by 2. I will convert this into positive indices by taking it in the denominator. X raised to 3 by 2 is nothing but x root x minus, I am converting it into positive indices by taking it in the denominator, x square root x, x raised to 5 by 2 is x square root x, minus negative indices to positive, take it in the denominator, x cube root x. So that will be your answer, right? Let's see another sum, guys. Y is equal to 2 root x plus 5 into 2 minus 3x. Same thing, differentiate with respect to x. So you will get dy dx of y is dy dx of 2 root x plus 5 into 2 minus 3x. Here there is multiplication between two terms. Whenever there is multiplication between two terms, you have to use UV formula. That is the only formula in derivative which has multiplication between two terms. Assume the first term to be u, assume the second term to be v. Now, if I use the UV formula, dy dx of uv is v derivative of u plus u derivative of v. V derivative of u plus u derivative of v. Assume the first term to be u, assume the second term to be v, and you are through. Now, this is 2 minus 3x, open the bracket, 2 as it is, dy dx of root x, formula 1 upon 2 root x, plus dy dx of 5. Since there is no x term in it, this is constant, and dy dx of constant is 0, plus 2 root x plus 5. dy dx of 2 is 0, constant. dy minus 3, dy dx of x is 1. So in this case you will get 2 minus 3x, 2 and 2 gets cancelled, upon root x plus 2 root x plus 5 into minus 3. Now you can simplify this as 2 upon root x minus 3x upon root x plus into minus minus 6 root x minus 15. This can be written as 2 upon root x minus 3 root x, because x upon root x will give you root x, minus 6 root x minus 15, 2 upon root x minus 9 root x minus 15. That is your answer. Let's move on to the next sum, guys. Y is equal to x raised to 4 sec x plus tan x. Same thing, differentiate with respect to x, multiply both sides by d by dx. So you will get d by dx of x raised to 4 sec x plus tan x. Now here open the bracket, d by dx of x raised to 4 sec x plus d by dx of tan x, right? Since there is multiplication between two terms here, you will use the UV formula. Assume the first term to be u, assume the second term to be v. So v derivative of u plus u derivative of v, right, plus dy dx of tan x is nothing but sec square x. Now again apply the formula. This is going to be sec x dy dx of x raised to 4. You will apply the formula dy dx of x raised to n, n x raised to n minus 1 plus x raised to 4. Dy dx of sec x is nothing but sec x tan x plus sec square x. Now this can be written as, there is sec x common in all the three terms, so I can take sec x common. This is going to be 4x cube plus x raised to 4 tan x plus sec x. Now that will be your answer. Fine. Let's move on to the next one, people. Y is equal to x plus root x upon x minus root x. Now when you have two terms, what you have to do is assume the numerator, when you have division, assume the numerator to be u, assume the denominator to be v. Now there is only one formula in derivative for division, that is u upon v. Apply that formula. Differentiate with respect to x. So dy dx of y is dy dx of x plus root x upon x minus root x. Apply the u upon v formula, the division formula. This is v derivative of u minus u derivative of v upon v square, right? This can be written as x minus root x. Now dy dx of x is 1, dy dx of x is 1, dy dx of root x is 1 upon 2 root x minus x plus root x. Dy dx of x is 1, dy dx of root x is 1 upon 2 root x upon x minus root x the whole square. Now simplify this. X multiplied with this bracket will give you x plus x upon 2 root x. Root x multiplied with this bracket is minus root x upon 2 root x. Similarly, simplify the other bracket. X minus x upon 2 root x plus root x minus root x upon 2 root x upon the denominator as it is. So this is x minus root x the whole square as it is. This is x plus, this is going to become root x upon 2 minus root x minus 1 upon 2, open the bracket, minus x, minus into minus plus root x upon 2 plus into minus minus root x minus into minus plus 1 upon 2 upon x minus root x the whole square. Now let's see what all cancels. Plus x minus x gets cancelled, minus 1 by 2 plus 1 by 2 gets cancelled. Root x by 2 plus root x by 2 is 2 root x by 2 minus root x minus 2 root x upon x minus root x the whole square. 2 and 2 gets cancelled. You could take root x minus 2 root x is minus root x upon x minus root x the whole square. That's your answer. Right? Let's move on to the next sum, people. Y is equal to sin x upon 1 minus cos x. Right? Let's see the sum. I can say that differentiate with respect to x. So you will get dy dx of y is dy dx of sin x upon 1 minus cos x. U upon v formula, v derivative of u minus u derivative of v upon v square 1 minus cos x the whole square. Now this can be written as 1 minus cos x dy dx of sin x is cos x minus sin x, dy dx of 1 is 0, dy dx of cos x is minus sin x. That minus multiplies with this minus sign to give you plus sin x upon 1 minus cos x the whole square. This can be written as 1 minus 1, no, this is cos x into cos x, so cos x into 1, cos x minus cos square x minus sin square x upon 1 minus cos x the whole square. Here I could take minus sign common. If I take minus sign common, this is cos square x plus sin square x upon 1 minus cos x the whole square. Now I'll continue this up there, guys. This can be written as cos x as it is minus cos square theta minus cos square theta plus sin square theta is 1 upon 1 minus cos x the whole square. I could take minus sign common in the numerator, so you will get 1 minus cos x upon 1 minus cos x the whole square. 1 minus cos x and square gets cancelled. Answer is minus 1 upon 1 minus cos x. Fine. Let's see another sum, people. Y is equal to cos x plus sin x upon cos x minus sin x. Right? Same thing, using the division formula, differentiate with respect to x. Dy dx of y is dy dx of cos x plus sin x upon cos x minus sin x. Right? U upon v formula, so this is going to be v cos x minus sin x dy dx of cos x plus sin x. I think I'll start the sum again because there's not much space here. Let's start the sum again. We've done up till here dy dx of cos x plus sin x upon cos x minus sin x. Now this can be written as, this is v upon u, sorry, u upon v, so this is going to be v derivative of u minus u derivative of v upon v square cos x minus sin x the whole square. this is nothing but cos x minus sin x. D by dx of cos x is minus sin x plus d by dx of sin x is cos x minus cos x plus sin x into d by dx of cos x is minus sin x minus d by dx of sin x is cos x upon cos x minus sin x the whole square. Now this is cos x minus sin x, cos x minus sin x. So this is cos x minus sin x the whole square minus. Now between these two terms I can take minus sign common. If I take the minus sign common, this will become plus. So this will become cos x plus sin x the whole square, because I have cos x plus sin x here. Minus sign I have taken common out here, so this will again become cos x plus sin x upon cos x minus sin x the whole square. This is going to be equal to a minus b the whole square. Therefore this is a square minus 2ab plus b square plus a square minus 2ab plus sin x cos x 2ab plus b square upon cos x minus sin x the whole square, right? Minus 2 cos x sin x this is minus 2 sin x cos x plus 2 sin x cos x gets cancelled. Cos square x plus cos square x is 2 cos square x. Sin square x plus sin square x is 2 sin square x upon cos x minus sin x the whole square. You could take 2 common here in the numerator. If you take 2 common in the numerator, this is going to be 2 cos square x plus sin square x upon cos x minus sin x the whole square. Cos square theta plus sin square theta is 1, so 2 upon cos x minus sin x the whole square. So your answer is going to be 2 upon cos x minus sin x the whole square. This finishes this chapter, right?